In this question, to reel a stone tied to a cord, one has to move the free end of the cord on a circular path, pulling the stone on a larger circular path. In this way, a stone of mass small m is reeled on a horizontal circular path of radius capital R with the help of a light and extensible cord of length L by moving the free end of the circular path of the radius R with a uniform speed v, as on this figure. At sufficiently great speed v, tensile force in the cord becomes so large that the effect of gravity can be neglected. So we can neglect the gravitational force, but at this speed air resistance becomes considerable. Find suitable expression for the force of air resistance. Acceleration due to gravity is g. So this is the path of the hand, and this is performing circular motion of radius r with speed v, uniform speed v, and this stone is moving along this circular path. Its center is the common center with this, and radius is this capital R. So let us start solving this problem. So I am assuming this particle is moving with some velocity. Let's say this velocity is u, and obviously time taken for one revolution of this hand will be equal to the time taken for one revolution of this stone. They will simultaneously complete their one revolution, so angular velocity for both should be equal. Okay, so angular velocity for both should be equal, and for angular velocity of this stone we can write v by small r, and for angular velocity of this hand it is v by r, and for angular velocity of this stone this is simply u by this capital R. And from here we can find u in terms of the given parameters v capital R upon small r. So this is the velocity of this particle. What are the forces acting on this particle? So one force is due to this string, which is the tension force. So let us draw the free body diagram. So this is, let's say, the tension force. We don't have to show the gravitational force here. So this is the tension force, and you can see that tension component of tension along this line, that is toward the center, will provide the necessary centripetal force, and tension's component in this direction will be balanced by the air resistance force. Air resistance will be opposite to this velocity. So air resistance force, let's say this force is capital F. So this is the force due to air resistance. Tension has two components. So for doing components, let me assume some angle. Suppose this angle I am assuming to be equal to phi. If I extend this tangent, suppose this angle is, let's say, theta, and if you draw a line here like this, so this angle is phi, and you will find that this angle will be 90 minus phi, and this angle is again phi. So this angle, you can see, this is theta plus phi. So component of tension towards center will be t cos theta plus phi. Okay, sorry, it is t sin theta plus phi toward the center. So let us write the Nlm equations. So it is t sin theta plus phi. This is towards the center, which is equal to the mu square by r. This is providing the necessary centripetal force for this motion, and you can replace u using this equation. So this is m by r, this is v square by r square by r square. One r will be cancelled, so it is m r by r square into v square. So this is the let's say equation number 1. Tensions, this component along this velocity is balancing the force due to air resistance. So this is equal to the force due to air resistance. This is my second equation. So we have to find this force, and equation number 1, it is in terms of, this is sin theta plus phi, and theta and phi are variables chosen by me. So let us remove these two variables by squaring and adding these two equations. So if I square and add, so t square will be common, it will be sin square theta plus phi plus cos square theta plus phi, that will be equal to 1. So it is t square, and here you will find this is mv square r divided by r square, this whole square, plus f square. So if you see this equation, so if you find the tension, so after finding tension we can easily get this force F. So now our focus is to find tension in the string, and how to find tension, I can use this equation t sin theta plus phi, this is equal to this. So from this equation I need to find tension, and for tension I need to find this value sin theta plus phi I need to find, and this length is also given, so I am going to use this geometry. Okay, so how to use this geometry? Let us make the diagram. So this is small r, this is this L length, this is small r, and this is the radius capital R. What are the angles? Angle is phi, and here this angle you can see this is 90 minus theta plus phi. Okay, this is 90 minus theta plus phi, and I have to find sine of theta plus phi. So I can apply cosine rule for this angle, and I will write cos 90 minus theta plus phi, that will become sine theta plus phi. So I can write cos rule. So this is 90 minus theta plus phi, ultimately it will become sine theta plus phi. So it is from this triangle I can write this is L square plus R square minus R square divided by this is 2LR, and it is sine theta plus phi. So I can put this sine theta plus phi in this equation number 1, and I can find tension in terms of the given parameters. So tension in terms of given parameters, so this T is mv square R divided by this R square divided by this value of sine theta plus phi. So it will be like this. This is 2LR divided by, after dividing. So now I can put this value of T in this equation, and I can find this force F. So force of air resistance, from here I can write this is F square, and this is T square, so this whole will be squared. And you can see this is the same thing, so it will be common here, and I can take it as common. This is 2LR, and you have to T square, so it is square. So L square plus R square minus R square, this is whole square minus 1. So now you can take the square root, and that square root will give you the force. So final answer for this will be F is equal to, so square root mv square by R square, square root of this is 2LR divided by L square plus R square minus R square whole square, this is minus 1. So this is going to be the final answer.